Hi. The purpose of this video is to demonstrate independent samples t-tests. In this case, we're going to use the teen survey data set, and we're going to run an independent samples t-test to determine whether scaled vocabulary scores differ by gender. So the null hypothesis in this case would be that the scaled vocabulary scores in populations of males and females are equivalent. Gender in this case is scored 0 and 1. To understand how that has been scored, we can look at variable view, and under gender we can see that 0 stands for male, 1 stands for female. We go back to data view to actually run the analysis. We click on Analyze, Compare Means, and move on over to the independent samples t-test. Click on that. We're going to make sure that scaled vocabulary scores get sent to the test variable and that gender gets sent to the grouping variable. In defining groups, one group is going to be a 0 because that's the low code for gender, and the other one is going to be 1 because that's the high code for gender. Once that is set, we can check our options to determine our confidence intervals that will be provided. In this case, and this is the default, it's 95% confidence interval. We can generally let the options go free within the independent samples t-test. Click Continue there and click Continue or OK again. We have our results. And what we're seeing here is that of the 155 males and the 145 females, the average mean for the males was 52.98 with a standard deviation of 10, and for females it was 52.43, slightly less than the males, with a standard deviation of 9.76. These standard deviations are very close to each other, so we can be optimistic that we will be able to meet the assumption for homogeneity of the variances of these two groups. When we subtract 52.43 from 52.98, we get a mean difference, or differences in the means, of 0.553, so about half of a scale score point difference. We're going to try to determine whether or not that amount of difference is greater, significantly greater than we would have expected due to random sampling fluctuation alone. The first thing that we see within this test is the test for homogeneity of variance. This is a critical assumption, and since the significance level here is greater than 0.05, we do not reject the assumption of homogeneity of variance. The null hypothesis in terms of this test is that the two variances are equal. In this case, we do not reject that null hypothesis because though this value here of 0.841 is greater than 0.05. So that means we'll be able to use this upper row, those that are tied into the equal variances. This row down here is based on a Satterthwaite conversion, and that we use that when we fail to meet the assumption of homogeneity of variance. To calculate the t-test, we divide this mean difference of 0.553 by the standard error of the difference between the means, which is 1.146. We get this value here by knowing the sampling distribution. The sampling distribution of the differences in means is calculated based on the size of these two samples. This tells us that simply due to random sampling fluctuation alone, given our sample sizes, we would expect a mean difference, or a difference in the means, of about 1.15 scale score points. And again, that is the difference that we would expect on the average just due to random sampling fluctuation. This is the standard deviation of that sampling distribution. When I divide 0.553 by this 1.146, I get the t-value of 0.483. That is, the observed difference of 0.553 divided by the kind of the anticipated difference of 1.146 due to random sampling leads to a ratio of 0.483. That means the difference that we observed was just slightly under half of what we would have expected due to random sampling fluctuation alone. Because that value is so low, we find a significance value that is much greater than 0.05. The difference of 0.553 that we observed would have occurred due to random sampling fluctuation alone 63 times out of 100 when we're drawing samples from a situation where the null hypothesis is true. As a result, we cannot conclude that there is a difference in the means of these populations. We do not reject the null hypothesis. These confidence intervals here are basically provided to demonstrate that 0 falls within the interval that is accompanied when we look at the 95% range of values where the true scores might fall.